I come to the next chapter, bulk chargers and swap station. Remember, this is for swapping. What do bulk chargers need? Bulk chargers charges the batteries together in one single unit, multiple batteries. Why? Because people will keep on coming, I have to keep on giving them battery. I have to swap in a couple of minutes, I can't make them wait. So, it will have maybe a 6, 12, 10 batteries, 20 batteries, 30 batteries charging. So, high efficiency is very important, because you are consuming a lot of power, you do not want loss. So, these chargers has to be not 90%, more like 98%. You will have to of course have communication with batteries, communication with server, reporting the charged battery status, is it charged, not charged, and data capturing from the batteries. Theft free, I have already talked about, use lock smart battery. Pay per use has to be incorporated. So, you should be able to bill with that battery very quickly, a Bluetooth communication will be there and you immediately charge, and it must make economical sense to the service provider. So, there are two models, charging, swapping and distribution at one place. This is preferable. Other is hub and spoke, charging at a common place and then you distribute at the distribution place. You will require a lot of transport here. So, what are the things that you require? You of course require swapping stations. You need communication with the central information management system, because this is what is going to tell you what battery is ready, what battery is not ready, how long it is taking place, and then there of course has to be user communication, even to sort of say I am coming there, I want a battery, please make sure that I have a battery available. So, plus this will also read the battery and locking, that in lock smart case can also be defined. Centralized charging station, there are bulk charging station, everybody, and these are the swapping outlets. There are multiple such swapping outlets. You keep on transporting in a vehicle all these batteries back and forth. So, one can do that and you will get more interfaces and more complex. This is, both these slides have been taken from Esmitho, because Esmitho is trying to use that. There are some attempt to define international swapping standards, very much in the infancy. There is a 61851-3 correction or removal battery system to BSS. It is made it independent of state of charge, state of health, chemistry and performance. Implementation of hazard identification and risk assessment, and then you have defined three kinds: full automatic, semi automatic and manual. There is a 682400 standard. Battery substation mainly include electric vehicle swapper battery system, storage for EV SBS, charging and cooling, and testing and maintenance. And there is some attempt to standardize swap station layout, not really standardize, more as a guideline. The vehicle is coming in, you will swap and the vehicle will move out. So, this is the thing. There are various two standards, 61851-3-3 and 68240. This is for LEV, low end vehicle, this is for very high end vehicle. It has a 1000 volt AC and 1500 volt DC. These are mostly 480 volts up to 400 volt DC. These are primarily for smaller vehicles, these are for larger vehicles. Okay. I am not going to get into details of this. The comparison 2 continues, applicability, the classification of vehicles is defined. This is all from commercial vehicles, and definition of interfaces are also defined. There is a proposal to merge the two standards, but right now 2 committees are going through this, and I have already gone through this. So, just a repeat slide. This is what will make the lock smart battery on the cloud. There are bulk chargers, and there is a swapping outlet. At swapping outlet, use mobile phone to lock the battery, and that is what is done. So, I will just skip this. Protocols in a nutshell: all kinds of driving protocols in a vehicle. This is important if you want to collect the data. Then charger to OMS and OMS to CMS protocol, we have been talking enough about this. Handles to CMS protocol is another thing that is kind of defined. That brings me to the last chapter of this chargers and management of chargers and vehicles, and I did this jointly with Dr. Prabjot Kaur, who is now in SMITO. Basically, the objective is, since they are electric vehicle, can I remotely monitor them? What do I need to monitor? Well, I could be monitoring everything. I could be monitoring the motors. Why? I like to understand the performance of the motors. I like to understand where motors are really giving me what I want. Could I have improved the motors? Is the motors something going wrong, likely to fail? I can anticipate all these things. Battery is a very important parameter, very expensive, whether it is a fixed or swappable. What is happening to my battery? I can remotely monitor, improve the performance, and what is called vehicle control unit, which will also monitor all other things. How am I driving? Am I driving too fast? How is it captures also driver behavior. Now, all these things are communicating to each other. All have powerful processor memory, they communicate with each other. They can store data while driving, while charging. Charging primarily the battery, others during driving. And data can be uploaded to a server using a wireless interface, or sometime you actually only upload during charging. So, then the charger has to have that interface. Then it is possible to analyze behavior of every aspect of the vehicle, and data analytics can help improve subsystems driving behavior and warn of potential faults. As I pointed out, batteries are made of hundreds of cells, and performance of each cell matters. Even a single cell failure will impact the whole battery. So, you monitor each cell. You can monitor chargers, can communicate with server and can upload vehicle data. So, if there is no wireless, it can upload data from the vehicle. Every time you come from charger, it uploads and then tells you what is happening. There is a charger to what is called operator management system communication. Monitoring and management, routine management messages, diagnostics, it will keep checking health, events and alerts, something has happened, when did it happen, why did it happen. During charging times, messages relating to charging. During driving time, messages related to discharging. Software management, which is the updated software there, and heartbeat, periodic heartbeat messages from charger to OMS. This is one thing that is getting standardized. Another is OMS to central information management system. Was once again charging, reporting, events and alerts, software management, inventory update. This is more for swapping and OMS heartbeat messages. So, OMS overview during swapping, if there more than one battery needs to be put into a vehicle, sometimes two-way batteries are put, then battery pairing is important, both must be charged to the same extent. Are there enough, if there are many outlets, are there enough batteries at each outlet ready if somebody comes from swapping? Optimizing the battery health, optimizing cost. charger, is it charging or is it off, and then 3-phase load balancing. If there is 3-phase, you do not want all the load to be on one phase or second phase, you want balancing. Battery charger fault troubleshooting, battery dispatch management, display which charger connects, charger and connectors are idle, which is in error, which is being used for charging, authentication and authorization protocols, and functions to manage. All these are part of definition of a business, which will make the energy operator work. And if you see, I will show you some of the picture. This is a bulk charging stations, and the color code will tell you what is free, it is charging and charging completed and battery is sitting there, or if there is an error. This is the kind of data that needs to be available for you to figure out what is happening at your bulk charger. What are the batteries that should be paired, that also can come out, and if there are charger configurations that need to be enabled, disabled, and connector configuration enabled, disabled. You then try to also figure out how much was charger utilized, what was charger point 1, how much was utilized, what was charger point 2 utilized, all these reports that you can take, and you can see what connectors are utilized. It is important. This is what will make the business work. And today with IoT this comes possible. What is the energy consumption of the charger, and each charger how much energy consumption they do? Should I rebalance and make sure that some chargers are more used than the others, and each energy consumption in each connector, there may be 20 connectors, what did they use? So, last 24 hours usage patterns, when was how much used? Very important for you to plan. Is there, you are deploying capital at each charge swapping outlet, is it being utilized sufficiently? Should you use it differently? And last 24 hours usage, day versus night usage, connector day versus night usage, weekdays versus weekend usage, connector weekdays versus weekend usage. Then the CMS, the CIMS, the information management system, it will manage your inventory management, OMS monitoring, maximizing extra battery requirement. Remember that if there is 100 vehicles that are swapping, you could need as much as 200 batteries, maybe 100. If you can optimize it to 130, 150, it will be great. Demand prediction and supply, how many batteries will be required at each place? Battery health and analytics and measurement, vehicle driving pattern, software version management, payment management, present location of BCS and swapping, utility interface and functions to manage. All these will make your thing work out. And then there is a map view, you can actually check out what is happening at each place, at each outlet, and what is not happening. Then it gives you time based reporting completely, and but one level higher, battery charging and time energy, what is happening, vehicle performance comparison you can do, and handle device functions. That is the next important thing. Logistic monitoring, the ones which are going to ensure the battery is supplied at the right place. Battery interaction app, verify whether battery model coming back, was it assigned to the vehicle, unpair the batteries, repair, get energy consumed, charge, all those things has to be taken place. And this is a kind of step by step function. What you need to do, basically you have to make payment to it and get the battery swapped. So, you have to worry about multi-level hierarchy. If you see, this is being done owning 3 bulk chargers, this is another one, this is another one, and you need to sort of worry about whether you will like to share things, and you can have a national level information management system. So, this will make the business really proliferate. We have been doing this for last now almost 4 years. These are vehicles which were used on IIT Madras. They were test vehicles parked at CBIF, which is next to ICNSR at IIT Madras, and they used to continuously operate all the way to research parking and to the gate every day. And this is the battery swapping picture. So, the person is taking, reading and then disconnecting, taking the battery out and bringing another battery, and then doing this, the reading being taken and battery is being assigned, and then battery is ready, and then you can drive on. That is pretty much it. How is the data useful? Driving pattern, vehicle and batteries tracking, inventory management, demand control, feedback for improvement, business case. I have one last thing, again I did with Dr. Prabjot Kaur. Essentially, as I pointed out, you can do a lot of analytics, monitoring of EV systems. So, you need data from every subsystem. You can go through this, there is really nothing very much. You can have a direct 2G, 4G connectivity, or connect to the or through the charger, and all these things can then be. How can battery send data? Battery could send data to the cloud directly, alternatively it could send data through the charger. It also tells you that during driving this battery has SOC imbalance. Either something is wrong with the vehicle or the battery, mostly with battery, and you can figure out. This is again cell voltage imbalance is there, you figure out and you take it out of service and repair it, otherwise battery will go for a toss. Cell level data monitoring, are there cells which are not behaving well? All the 26 cells you will monitor in a 2-wheeler, 3-wheeler, and time spent by batteries at different temperature during driving. Sushant has been collecting this data, what has been the temperatures, and all these temperatures will hurt or help the vehicle. You also try to look at it, thermal management, what is happening, you have various sensors and what is going on, and energy usage of batteries, different batteries, how are you using it, and of course, life cycle prediction and safety risks and alerts. There are various tools used for analytics, simple statistics, machine learning, artificial and model based analysis, pretty much that is. Last 2 chapter I just gave you overview very quickly, so that last 2 subsection of this chapter, saying that if you want to drive a business with battery swapping in particular, what all you have to do. So, we are pretty much done with the electric vehicle part of the course. From next year onwards, we will move to renewable energy, solar, wind, grid storage, we will look at that. Please do your assignments, complete everything. These chapters have given you a fairly, 7 chapters have given you a fairly comprehensive idea of electric vehicles. Let us move on to the renewable energy and the grid. Remember, the renewable energy and the electric vehicles go together. Objective is not to make electricity from coal and drive electric vehicles. That is better than driving oil based vehicles, but still coal based electricity is going to give a lot of pollution. Objective is to use renewable energy, and we will discuss the renewable energy in the next class. Thank you very much.